Hello, my amazing students. This is Mrs. A, and I love math. And we are here with lesson 19 in your Saxon Orange book, Algebra I. So we're talking about exponents, powers of negative numbers, roots, evaluation of powers. So this is a big lesson. And we're going to learn about exponential notation, which is a shorthand or shortcut for expressing 5 to the 7th power is read 5 to the 7th power. Okay, it can be read 5 to the 7th or 5 to the 7th power. And 5 times 5 times 5 times 5 times 5 times 5 times 5. So there's 7 5s, and altogether it's a really big number. But we can shortcut all of that by saying 5 to the 7th. Now, this is the expanded form. We've taken this and written it all out, and it takes a lot of writing. This is the exponential form, and it's so much easier to use. So by definition, our exponential notation is we have x is the factor, but then we have n of those factors, and so it's going to be x to the nth power. So this n is the exponent, and the x is the base, or the number that is receiving the repeated multiplication. So let's look at the next one here. For example, okay, x to the 4th is x times x times x times x, where x is the base and 4 is the exponent. Negative 4 cubed means negative 4 times negative 4 times negative 4. Negative 4 is the base, and number 3 tells you how many times negative 4 is multiplied by itself. So that's the number of factors that are in there that are repeated. And 2 to the 4th is 2 times 2 times 2 times 2, which is 16. So we would say 16 is the 4th power of 2. So those are just some vocabulary words that we need to learn how to use involving exponentials. Okay, so let's continue with 19b, where we're going to learn some rules. So when we take a positive base and we raise it to a positive exponent, we will always get a positive number resulting. Right? So here's some examples. We take a positive number 3 and we multiply, or we raise it to the 2nd power. Can you see that? I'm thinking maybe I got it a little bit small, but let's try. Raise it to the 2nd power. Then that's the same thing as 3 times 3, which is 9, positive number. And here we have a positive base 3 raised to a positive power, or exponent 3, is the same thing as 3 times 3 times 3, which is 27, which is positive. Okay, 3 to the 4th power is 3 times 3 times 3 times 3. There's no negative sign anywhere, okay, and we're going to end up with 9 times 9, or 81, which is a positive number. Now here, we have a negative number thrown in, but we have to be very careful. The negative is out here in front, and the negative is not tied to the 3. So we're going to learn very shortly, order of operations. We always have to do the exponent first. This is the same thing as negative 3 to the 4th. Okay, so in other words, only the 3 is being raised to the 4th power. The negative is just out here in front. So this is the opposite of 3 to the 4th. Well, we just found out what 3 to the 4th was, is 81. So the opposite of 3 to the 4th will be negative 81. Now, we have to be very careful with these. If I had included that in a parenthesis, then the base would have been negative 3 instead of 3. And then it would have been negative 3 times negative 3 times negative 3 times negative 3. And that we'll deal with in the next one. It still would have been positive, wouldn't it? Because we have 4 negative numbers multiplied together. But that's not what they said. They left it with no parenthesis, and therefore it's the opposite of 3 to the 4th, which is negative 81. So there's your board, and I'm coming back with the next one here. So we're still in section 19b, and we have 2 rules that we're going to learn here. When I have a negative base raised to an even number, raised to an even power, then I will always get a positive number resulting. If I have a negative base raised to an odd power, I will always get a negative number resulting. Okay, so let's look at some examples. I have a negative base raised to a 2. Well, 2 is an even number, so I should get a positive number. Let's see. This is going to be negative 3 times negative 3. I'll put those in parentheses just so I don't get confused. And that's going to be a positive 9, which is what our rule said. Okay, so I've got negative 3. Oh, I think this was supposed to be a cube here. I think I misread it wrong. Let me look. Yes, it was a cube. Okay, so negative 3 raised to the 3rd power. Well, 3 is an odd number. So that's going to be negative to an odd is a negative number. Let's see. Negative 3, negative 3, negative 3. Negative times negative is positive, but then positive times negative is negative again. So we get negative 27. Okay, so we ended up with a negative number as we were told we would in our rule. So here's a negative base raised to a even number, therefore we should get a positive number result. Negative 3 times negative 3 times negative 3 times negative 3 is 3 times 3 is 9, 9, 81, but then our signs are going to go negative times negative is positive, positive times negative is negative, negative times negative is positive again, so we get a positive 81, and that's what our rule said we should. Now here we have the negative 3 to the 4th power, but then we have this negative sign which is out front. It's not connected to the negative 3, so that is the opposite of this quantity, and so that's going to be a positive 81 with a negative sign in front is a negative 81. Okay, so we had the negative base raised to an even power. So this part here was indeed positive, but then we took the opposite of that, so now it's negative. Okay, so here in 19.3, we have an example. We're going to do this problem, piece it apart. Now, you see this negative 3 is not included in a parenthesis. So remember that exponents get done first. So this is going to be negative 3 times 3 times 3. Well, 3 times 3 times 3 is 27, isn't it? So negative 27. And then this minus, we'll just put it down here so we don't lose it. Negative 3 squared is a negative raised to an even power, so it should be positive. So that's going to be the minus here, and then a positive 9, plus negative 2, which is a negative raised to an even power, which will be a positive number. Negative 2 times negative 2 is positive 4. So when I put all those together, I get negative 27 minus 9 is negative 36, plus 4 is negative 32. More examples to follow. Okay, so here is 19.4 example, and we've got this long expression that has some powers in it that we're going to have to work on. So this one, remember the negative is not connected to the 2. There's no parenthesis. So we're going to do the 2 squared first, and then we're going to say that's the opposite of the 2 squared. Well, 2 squared is 2 times 2, which is 4. The opposite of 4 is negative 4. Okay, so I'm going to pull this apart. So we're going to go ahead and write down our negative 4. and we're going to evaluate negative 3 cubed. Now, this is where our order of operations is coming in. We always raise it to the power before we worry about this multiplication here. So we're going to do this first, and that's called order of operations. So we're always going to do the power first. Negative 3 times negative 3 times negative 3. There's 3 negatives, so it's going to be a negative number, and it's 27, isn't it? So we're going to put negative 27. And then we'll come back and do this in a minute. Then we're going to come over here. This exponent is going to take a higher priority than the negative 2 times. So we're going to just write down the negative 2. Negative 2 squared is negative 2 times negative 2, which is 4. And then lastly, a minus 2. So now let's go clean it up some more. So I'm just going to bring down my negative 4. I have a multiplication here, which is a higher priority than this minus is. Okay, so I have to do the multiplication first. So that's going to be 27 times 4. Now, I don't know that right off the top of my head, so I'm going to multiply it out. 28, 8, 9, 10, 108. Okay, so positive 108. Oops. Minus 8 minus 2. Okay, so negative 4 plus 108 minus an 8 minus a 2. So negative 4 plus 108 is 104. Minus an 8 is a 96. Minus another 2 is a 94. Okay, so now we're moving into part C of our lesson, which is roots. Okay, so let's just explore a little bit. 3 times 3 is 9. So 3 squared is 9. And this symbol is the square root symbol. So the square root of 9 is 3. And the square root symbol just means, okay, go find the root, which is the number that when squared gives you 9. That number is the square root of 9. So 3 is the positive square root of 9. So if I had 3 times 3 times 3, I'd get 27. So 3 cubed is 27. Therefore, the cubic root of 27 is 3. So our radical is undoing the power, isn't it? It's going backwards on that power process. So let's look at the next little part here. We have some really cool rules to help us think about these things. If n is an even number, every positive real number has a positive nth root and a negative nth root. So let's look at these, okay? If I took 3 times 3, I would get 9, okay? So 3 squared is 9. But what if I took negative 3 times negative 3? I would still get 9, wouldn't I? So negative 3 squared is 9. So doesn't it make sense that 9 will have a positive square root and a negative square root? Because I can square 3 and I can get 9. And I can square negative 3 and also get 9. So 9 is the square. The square root of 9 is 3 or negative 3. But in order to have a uniform rule for all the world, because the whole world does it this way, okay, this is a convention that everybody has accepted, the square root symbol will always mean the positive of the two roots, okay? So if there are two roots, it will always be the positive. So that's going to be our convention. So here we have 3 times 3 times 3 times 3, or 3 to the 4th is 81. Therefore, the fourth root of 81 is 3. Now, true, if you did negative 3 to the 4th power, you would also get 81. So negative 3 is also a fourth root of 81, but we are going to use this symbol this radical symbol to always mean the positive of the two roots. So here we have 3 to the 5th power is 243. So the 5th root of 243 is 3, which is the positive 5th root. Okay, so there's your board. Okay, so here we have 9 is the radicand, because the number underneath the radical is going to be called the radicand. And this, although we don't have anything there, whenever there's a number missing, like this one has a 4, there's nothing in that little hook of the radical sign, that means it's a 2 understood. Anytime we don't see a number, we understand it is a 2. So 2 is the index, which is the number of roots that we're going to take. So negative square root of 9 is going to be the opposite of the square root of 9. The square root of 9 was 3, so the answer is negative 3. On this one, the 4th root of 81 is 3. And here we can see that the 4th root of 81, 81 is the radicand, and 4 is the index. And if we want to indicate a negative 3, we would say the negative 4th root of 81. Since the 4th root of 81 is 3, because 3 times 3 times 3 times 3 equals 81, then the opposite of the 4th root of 81 will be the opposite of 3, or negative 3. So on this next board, we have some practices, 19.5. So the square root of 64, we have to think about what number squared gives us 64, and the answer would be 8, wouldn't it? Because 8 times 8 gives us 64. The 4th root of 16 means what number, when multiplied by itself 4 times, is going to give us 16, and the answer is 2. Remember that even though negative 2 would also give us 16 if it was raised to the 4th power, this notation means the positive of the two roots. So 2 times 2 times 2 times 2 gives us 16, therefore the 4th root of 16 is 2. The 3rd root, or the cubed root, of negative 27 is going to have to be a negative number, because I need a negative factor to get to a negative 27. So let's try negative 3. Negative 3 times negative 3 times negative 3. Okay, 3 times 3 times 3 is 27. And the negative times the negative gives us a positive and then a negative. So we're going to end up with a negative 3 as the cubic root of negative 27. And here, the negative is on the outside. So the square root of 81 is 9, because 9 squared is 81. So this is going to be the opposite of 9, which is negative 9. Right, so now we're moving into evaluations of expressions that include powers. So here we have an expression yx squared m cubed. So let's just suppose that y is 3, x is 4, and m is 2. So we're going to substitute these into the proper places. So y is 3, so we're going to put 3, and then the base x is 4, so we're going to have 4 squared, and then the base m is 2, so we're going to have 2 cubed. So let's evaluate each one. So 3 is just 3, 4 squared is 4 times 4, which is 16. 2 cubed is 2 times 2 times 2, which is 8. So we're going to wind up with 3 times 16, which is 48. Okay, times 8. So I'm just going to multiply that. 8 times 8 is 64. 4 times 8 is 32, plus 6 is 38, so 384. Okay, so now we have just one variable, but it is the base for each one of these expressions. So if a is negative 2, then a squared would be negative 2 squared, which is negative 2 times negative 2, which is positive 4. Okay, and then negative a squared. Notice the negative is out here, and there is no parenthesis. So we're going to have negative a, which is negative 2, squared. We have to do this first. So negative 2 times negative 2 is 4. The opposite of 4 is negative 4. Okay, negative a cubed. Again, the negative is not included in a parenthesis. So it's going to be the opposite of a, which is negative 2 cubed. We do the power first. So negative 2 times negative 2 times negative 2 is negative 8. But then the opposite of a negative 8 is a positive 8. And the last example on this board is negative a included in parentheses. So we're going to have negative a negative 2. And then this whole thing, I'm going to use a bracket so is raised to the third power. So negative of a negative 2 is a positive 2. So 2 cubed is 8. It's kind of fun, isn't it? Okay, this is our last board before we start our practice problems. So here's our expression, x squared z cubed y. And these are the values we're going to substitute in. So I'm going to kind of make a skeleton of my problem. So I'm going to pull out the x squared, pull out the z cubed, pull out the y. Okay, in place of the x, I'll put a 2. In place of the z, I'll put a 3. In place of the y, I'll put a negative 2. Okay, so now we've got 2 squared is 4. 3 cubed is 27. Negative 2 is just negative 2. It's not raised to a power, is it? So now we've got 4 times 27 times a negative 2. So 27 times 4 is 28. 8 plus 2 is 108 times a negative 2. Okay, so a positive times a negative will give me a negative number. And if I double that, don't I get 216? I don't even need to do the math, do I? All right, so here's our last non-practice problem. Pm squared minus z cubed. So I'm going to pull out my p. I'm going to pull out my m and put a square. I'm going to pull out my z and put a cube. So p was a 1. M was a negative 4. And z was a negative 2. So now I simplify. So I have a negative 4 squared, which is a positive 16. And positive 16 times 1 is still 16. Minus, now negative 2 times negative 2 times negative 2 is a negative 8. So what is the 16 minus a negative 8? That's a 16 plus 8. And 16 plus 8 is 24. And now we're ready for our practice problems. Okay, so here's our first practice problem. Negative 2 squared. So that's equal to negative 2 times negative 2. Negative times negative is positive, so we get a 4. Negative 2 squared. Now notice the negative 2 is not in a parenthesis. So this is the opposite of 2 squared. So 2 squared is 4. So the answer is negative 4. And this one is a little bit bigger, so we're going to pick it apart. So we have 3 cubed is 27. This negative is the opposite of 27. So that's going to be a negative 27. And then we have minus a negative 2 squared. Negative 2 times negative 2 is 4. So it's the opposite of 4, or a negative 4. And then a negative 2 squared. 2 squared is 4, so it's a negative 4 again. And I ran out of room, but it's negative 27 minus 4 minus another 4 is negative 27 minus, that's negative 31, negative 35. So there's your board. and we have a few more practices. Okay, so here we are with the next practice problem. The cubic root of negative 64. So we're looking for a number that when cubed will give us negative 64. That's what a cubic root is. So we know it's got to be a negative number because a negative times a negative times a negative would be a negative. So we know we're looking for a negative, and we're going to try 4 because I'm pretty sure that's it. But let's try it out and let's see. Okay, so negative 4 times negative 4 times negative 4. Negative times negative is positive, times another negative is negative. 4 times 4 is 16, times 4 more is 64. So that is correct. The answer is negative 4. Okay, so we'll take that off of there. We don't need that. The next one. Negative 3 is in parentheses, so it's negative 3 times negative 3 times negative 3. Because there's an odd number of negatives, it will be a negative 27. And then the cubic root of a negative 27. Well, we just figured out what we needed to multiply by itself 3 times to get a negative 27. So isn't this going to be a negative 3? And negative 27 minus 3 is negative 30. Okay, and this one we have negative 3 squared, but the negative is not in parentheses. So it's the opposite of 3 squared. 3 squared is 9. So it's going to be a negative 9. And then the cubic root of a negative 8, since it's an odd root, it has to be a negative 2. So this right here is negative 2, but then we have the opposite of a negative 2 is a positive 2. Okay, and then down here we've got negative, the square root of 16, but the square root of 16 is 4. The opposite of 4 is negative 4. So negative 9 plus 2 minus 4. Negative 9 plus 2 is negative 7. Minus 4 is negative 11. And there's your board. We have 2 more problems and we will be done with the lesson. Okay, so these are the last 2 problems. We're evaluating this expression given that x is negative 3, z is negative 2, y is negative 2. So we're going to start by making kind of a skeleton here. We're going to take out the x and put in a frame here for the replacement of x. So it's going to be parenthesis squared. Take out the z and put the cube. Take out the y, and now we're going to fill it in. X squared is now going to be negative 3 squared. Z cubed is now going to be negative 2 cubed. And y is replaced by the negative 2. So now we have to take care of the exponents before we do the multiplication because it's a higher ranking. So negative 3 squared is negative 3 times negative 3, which is 9. So we'll just put that right here. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. And the negative 2, these are all factors multiplied together to give us 9 times a negative 8. It's going to be a negative 72 times a negative 2. So negative 72 times a negative 2. Negative times negative is positive. And we're going to get a doubling of 72 would be 144. So 144 is the answer. And the last practice problem. B squared minus 4ac, which is something you're going to learn more about later. But we're going to have b squared, so we're going to put our little parentheses, squared, minus 4ac. We're going to go put the substitutions back in here. So b squared is negative 4 squared. And then the a is negative 3. and the C is -5. And -4 times -4 is 16. So we're going to end up with 16 minus, and then 4 times a -3 is going to be a -12. But then the -12 times a -5 is a +60. So we had this minus in the front of all of that. So 16 take away 60 is going to be 44, I believe, and it's negative. Let me make sure that's right. And it is -44. And we are done with lesson 19. This is Mrs. A, and may God bless your day.